Greetings to everyone watching this. My name is Russ Hatfield, and my twin soul's name is Kara, who is a member of Ashtar Command, a healer, and an ambassador. This is our latest lesson on the spacecraft and the pilots of the base. For this lesson, Kiri is channeling through Mark Crocker as we discuss the speed of light and travel times. We call this lesson Relative Time at Lightspeed. In it, Kiri and I go over a question that was asked by one of the followers of our webpage about the effects of the speed of light and a wristwatch. Kiri has fun with that answer before going into a more technical explanation of time inside and out of a gravimetrical field. To top things off, she reveals how a scout ship of theirs only takes 3 light minutes to get from the base to Earth. You can follow our online transcript at the link below of our homepage, centerforascension.org. Please subscribe if you want at the end of this lesson to be alerted to future channeling sessions, editorials from Kara and myself, and lessons from the Center for Ascension. And now, relative time at lightspeed.
The question is asked, would that mean that if you had some kind of chronograph or wristwatch, that it would keep different time for you than someone else? And this is if you're on a spaceship, what time system?
Yes.
And the answer is, in that sense, the chronograph will not work. The electromagnetic fields would allow it to not operate in the way that it was designed. So if you're on a spaceship, my wristwatch is going to not work anymore. Correct?
I think that's a laugh.
Kiri goes giggle, 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 giggle.
No, those other ones in between.
Or he. That's baloney. If you have a chronometer that works on electrical impulses, it will continue to work. Here is the reason. Because you are inside the electromagnetic field, it surrounds you, but does not penetrate you. Because it is all focused outside, externally, to create the gravimetrical field. You are inside the gravimetrical field, which means it does not interfere with you. Everything is focused outside. So therefore, the electromagnetical field does not affect you, because the gravimetrical field pushes it away. You're here on this side, right? This is the wall. Gravimetrical energy is focused out, right? And then the gravimetrical field pushes the electromagnetic field out, which gives the lift. Very simple. It is focused away from it. So your chronometer would continue to function. However, as you approach, as Amol pointed out, the speed of light, it would work at a slower rate than externally. Because time would be passing faster externally outside the field that you have generated. Things would seem accelerated. For example, let's just say my 2 fingers, or Mark's 2 fingers, are walking. That's normal speed. You inside would see this if you were looking outside.
So if it took 5 light years to get to Sirius.
Mm-hmm.
Okay. Well, let's take an hour. Let's say Sirius is 1 hour, or a light hour.
Okay.
Okay. Now, I get in a ship, and I travel to Sirius 1 light hour.
Mm-hmm.
Okay. Now, my watch is 9:30, and Karen has to go.
Okay.
But when I get to Sirius, is it going to say 10:30, or is it going to be a lot slower?
Now, it will say 10:30.
By love. But the actual time is different.
Correct. Extended. Bye, Karen.
The time on Sirius, then, is actually...
Take care.
Yes, you do.
I will.
Is actually 11:30.
Correct. You see, it's the relevant time.
Right.
Okay? Inside time will continue. If it takes you an hour to travel that distance, and it's only a light hour away, right? Then it takes you 1 hour to travel there. But that hour has more than elapsed.
I think I meant it to work if I start my car. Well, see you later.
It doesn't work.
Right.
You see what I'm saying?
Right.
Okay, now let us say that it is 1 light hour away, but you cover that distance in half the time.
Mm-hmm.
Takes you 30 light minutes.
Right.
Pardon me. Or pardon Mark's body, rather. So, what is happening? You are travelling at twice the speed of light, which means that you have travelled the distance from your planet to our planet in half an hour. Half an hour of your time. But an hour has actually elapsed from Earth time. It's only taking you half an hour. It's taking you half an hour. Let's say the times are exactly the same. It's 9:30 Earth time, 9:30 Sirius time, right? Your time where you're going to land. Okay? Half an hour has elapsed. It's now 10 o'clock for you, right? But because it takes light an hour to travel from there, it's 10:30 when you arrive there.
Right.
But meanwhile, back on Earth, 2 hours have elapsed. Return trip, right? How much time has elapsed?
Well, according to Malden, 4 hours would have elapsed.
Correct.
Now, how far is Hades space in light speed terms?
It's about 9 minutes.
10 minutes.
But this is where it gets tricky. We can get from Hades space to Earth, right, in about 3 minutes. That's from getting in the aircraft to getting to your planet.
Right.
But that's manipulation of dimensions.
It's a dimension.